I want to start with it's kind of where we picked off or left off yesterday. I want to pick up there today. Yesterday we were talking about conditional statements. Gave you a homework assignment, and I messed up the due date for fourth period. I don't know how many people, I sent you an email, I don't know how many people that's affected throughout the day. I'm just going to just kind of holistically change the due date for everybody. So if you didn't do 2-2 last night, you have an opportunity to finish that tonight. And I'll make that available here in a moment, or towards the end of the period. The conditional stuff yesterday, guys, I want to kind of talk about the purpose of this. First of all, everything that we talk about in regards to rules or properties, theorems, these collective statements that they give us that kind of govern mathematics are going to be provided as if-then statements down the road, okay? Whether they're in geometry, algebra 2, college algebra, trigonometry, calculus, anything beyond that in college. They're provided as if-then statements, okay? Sometimes those if-then statements are reversible, okay? But they'll never give you an if-then statement, say, in parentheses at the end of it. This is reversible. You can use it this way. What they do is they come up with another type of structure that ultimately tells us, because of the structure of the sentence, it's reversible. Okay? So kind of get into that a little bit towards the end today. But we are trying to determine, ultimately, when we look at a conditional statement, if-then statement, can I prove it? Is it true, and is it true all the time? And that's where when you hear me say the word proof, or talk about proving something, showing why something is the way it is, we're showing why it is the way it is all the time, okay? And that will be a huge task in this course, along with other courses, algebra, college algebra, trigonometry, calculus, that type of stuff. You'll do proofs intermittently through those other courses and try to teach you the structure of that now. Now, we introduced this structure because it's how all the rules are going to be provided for us. But we're really not going to use maybe the inverse and the contrapositive very much until later on. Maybe later this year, maybe next year. Maybe it won't be until you're a sophomore in college that you take a math class and you have to use what we call proof by contrapositive. But at that time, your professor is going to think, oh, this person graduated high school mathematics, so they know what a contrapositive is. Okay? And if they don't, they're a junior or sophomore in college, they might have the intellectual skill to go back and realize, oh, I don't know what contrapositive is. I need to go back and find out what it is, reteach myself, that kind of thing. Okay? But I want to show you, because there may be situations throughout the year that I give you a statement and it's hard to decipher. I look at this statement, it's not all that difficult, but this is an example where that might be hard to decipher. It might be hard to state whether that is true or false. Okay? So what we do is we say, if that's hard to decipher whether it's true or false, maybe I can create the converse, the inverse, and the contrapositive, and analyzing those might make it easier to determine what this one is, okay, whether it be true or false. So that's what I want you guys to do. I want you to take this from what we talked about yesterday. I want you to take about 3 or 4 minutes here, write down what you think the converse looks like, the inverse, and then the contrapositive, okay? And when you guys are doing these, a lot of times, maybe they give me the original statement in a homework question, they only want the inverse. Or maybe they give me the original one and they only want the converse. My suggestion is, when you get the original one, take a minute to write all of them down and write them down in the same order every single time. So I always do original, converse, inverse, contrapositive, okay? Where if you're doing a different order from question to question, you're not going to be able to recognize patterns on how I create the converse and how I create the inverse, because it is pattern-oriented in regards to the rules and how you create those things, okay? So come up with a structure. Like I said, I always go converse, inverse, and then contrapositive. If you want to go do something different, that's fine. But don't even worry right now about whether they're true or false. We'll answer those when we're done. All right, so hopefully you've progressed a little bit on that. The first one, okay, if my original was, if angle B is not obtuse, then measure of angle B is not equal to 81, okay? So the converse, remember, just takes the if part and puts that now as your conclusion, and it takes the then part and now it puts that as your hypothesis, right? So you see color coding there, you can see that those two phrases just switch positions in my conditional statement. Okay? Is everyone okay with that one? All right. The inverse then, guys, the inverse is starting back up with this one. So I'm just going to cut and paste this one out. Okay, but then I put a not here, and I put a kind of a not here. Okay, and we're going to talk about, in English class, we would not do that, right? We would not write not, because now you're making your reader think and kind of have to undo that without maybe an understanding of how to do that, okay? A not, though, turns into just that, right? When I negate a not, it goes away, okay? Here, when I negate, remember what this means, the way I've written this using symbols, okay? We've got the measure of angle B not equal, or not is, let's do it this way. It's kind of hard. So let's take that not out first. When I don't have that in, when I say measure of angle B equals 81, that equals would mean is, right? Does that make sense? Okay. So now if I got that slash through it, I really have measure of angle B is not 81. Okay, so that's what, underlying that stuff right there, that's what that would say. Measure of angle B is not 81. So if I negate that, there'd be another not right here with this not, right? Well, that will just cancel that out, and what's it leave me with? Angle B is 81, correct? I think people sometimes struggle with that because we're using a symbol instead of words, but when you have not equal to and you negate it, it becomes equal to. Okay? So, all right, everybody? The next thing you're going to do is you're going to take, to find a contrapositive, I take the original and I flip the order of them. Okay, so when I flip the order, it creates this one, right? Okay? And then I'm going to go through that one, and I'm going to negate the front, and negate the hypothesis, and I'll negate the conclusion. And it should give me that. Is that all right with everybody? So now I've created the converse, the inverse, and the contrapositive. Now it might be a situation where if I wanted to originally determine whether that first statement was true or false, and I struggle with that. Now if I look at the last one, the contrapositive, if measure of angle B equals 81, then angle B is obtuse. Is that pretty easy to determine that that is what kind of statement? That's false, right? Okay? So if that's false, automatically this one up here becomes false. And that's the idea. That's the purpose of contrapositives, understanding contrapositives, is that every time that I have a true contrapositive, that means the conditional that I used to create it was also true. Or every time that I have a false contrapositive, the conditional that I used to create it was also false. They're always the same truth value. Okay? Does that make sense to everybody? So a lot of times, guys, we'll go through, I'll show you an example of this with one that turns out to be true. But we might, at the onset, be provided maybe that as a true statement. Okay? Actually, let me go to this one here. We might be given, at some point this year, to be a true statement. And I want to prove that geometrically. I want to go through a system of steps that says this is why this is always true, no matter what values I use for these angles. This is always true. That might be impossible. Okay? I don't know whether it is or not, but it might be impossible. There are times that mathematically the things that are provided for us that we set out to prove are impossible to prove using the structure that they currently are in. But I might be able to come up with this contrapositive, which would be the statement there at the bottom, and I might be able to prove that pretty easily. Okay? Well, if I can prove that the contrapositive is always true, then I have effectively shown, because the conditional statement has the same truth value, then the conditional is always true as well. Does that kind of make sense? All right, so being able to understand the relationships between those things might allow us eventually to prove things a little bit easier. Okay? It kind of opens the door sometimes to being able to prove things that initially, the way they're structured and the way they're written in sentence form, because of our mathematics, we might not be able to prove them at all. But when I transform it to something that is equivalently true or equivalently false, that might then be easier to prove. All right, so now I get to the converse and the inverse. And here's the thing. When I talk about the converse and the inverse, because I've already decided that the original was false, that has no bearing on whether the converse or the inverse were false or true. Does that make sense? So you have to separately analyze these. Now, I'm a person, if I've got both of these, I'm going to look at the one that probably doesn't have the words not in it. I'm going to look at that one. That's the one that I feel most comfortable with. Okay? If angle B has obtuse, then measure of angle B equals 81. Is that a true or false statement? That's a false statement. That's always a false statement, right? Okay? Remember what we're doing. We're saying if we've got that thing in our hands, if I've got an obtuse angle in front of me in my hands, on my paper, on a test or whatever, they're saying if this was a true statement, then that obtuse angle is always 81 degrees. Well, we know that that's not true based off the math that we currently have under our belts, right? So we should be able to say that that's false. Okay? Well, if the inverse is false, I'm able to accurately answer that one. What do you think that tells me about my converse? It is false as well. Okay? So in this case, we get all four of them to be false. You could, depending on what the nature of your questions are, or your conditional statement is, they might all be true, they might all be false. Two of them might be true and two of them might be false, but you'll never have 3 in 1. Okay? And the argument for that, and we'll do one more example of this in a moment, but this is what we refer to these statements and their truth value, their trueness or falseness, when they're the same. Okay, when two statements, and it could be multiple statements, it doesn't have to just be two, but right now that's all we'll be focusing on. If I have two statements that are both true, we say that they're logically equivalent. Okay, if I have two statements that are always both false, then we have two statements that are logically equivalent. Okay, so if two statements have the same truth value, the same true or falseness, we refer to them as being logically equivalent. Okay, contrapositives in the original statement and the original conditional are always logically equivalent. No matter what one of them is, the other one has the same truth value. And then converses and inverses are the same way. If a converse is true, the inverse is true. If the inverse is false, the converse is false, and vice versa. Okay? The way I remember this, guys, is because a lot of people, we got 4 things going on here. People are going to mess them up, and they're going to group them incorrectly. Okay? I always remember the words that have verses in them. Those get paired together, right? And if one of them's true, the other one's true. Okay? And then by default, that leaves me 2 other statements that we haven't talked about, the original one and the contrapositive, so they must be linked together. Does that make sense to everybody? I try to do those types of relationships a lot, especially when we're trying to categorize things and link them, saying that they have the same characteristics. Develop some kind of device that allows me to compare them and remind myself all the time that these two go together, these two go together, and hopefully then when we get to a test or quiz, that's still there with us and we can answer those questions pretty effectively. So let's do another. Let's do one more, and then we'll jump into a continuation of notes with this stuff. So I want to delete the original. Okay. So we've got that phrase, because if angle 1 is not congruent to angle 2, then angle 1 and angle 2 are not vertical. So I want you guys to write your converse, inverse, contrapositive, and then again we'll reconvene and talk about those truth values. All right, as we go through this, and this just might be something that you see, I didn't write it this way in this question, but you see down in the bottom left, the phrase not congruent. Okay, you can obviously use, just like we say not equals to, we use the equal sign and then a slash through it. If I want to say not congruent, we can do that. Okay, we put that congruent symbol and then the slash through it. But another word that means not congruent is the word incongruent. Okay, so you might see those phrases, those synonyms or symbols for that phrase throughout your homework. Just want to make sure we understand what that means. So the original conditional statement said if angle 1 is not congruent to angle 2, then angle 1 and angle 2 are not vertical. Okay? So to come up with the converse, all we do is we take the if and then parts, right, the hypothesis and conclusion of the original, and they flip-flop. Okay? So if angle 1 and angle 2 are not vertical, then angle 1 is not congruent to angle 2. Okay? So that gives me the converse. The next thing I'm going to do is I'm going to go back up to the original. Okay? So this was the original. I cut and pasted it, and it became my inverse. and then I go through and I negate both the hypothesis and the conclusion of the inverse. Okay, so I went ahead and I put just an extra not in here in the front and the back. That means now I have a not, right? So not just wipes each other out. Back here, you have not again. They wipe each other out. And now my inverse is if angle 1 is congruent to angle 2, then angle 1 and angle 2 are vertical. Okay? Again, we'll come back and we'll talk about the truth value of these in a moment. Now I get to the last one. And again, the last one is taking the original one and flip-flopping the hypothesis and the conclusion. Okay? So we flip-flop the hypothesis and the conclusion, and then I negate them. Okay? So flip-flopping the hypothesis and conclusion gives me this thing right here. Okay? Then I negate them. So here's the negation of it. Okay? So not, so delete that out. And then we got this not, delete that out.
Can you leave a minute?
Yes, yep.
Can Andrew carry that?
That's fine.
Thank you.
Yep. All right, so we get those 4 phrases. Okay? If we were struggling at the onset to tell whether the first one was true or false, if angle 1 is not congruent to angle 2, then angle 1 and angle 2 are not vertical. If that's problematic, then we should know that that one there, that phrase right there, in this one, should be answered the same way, because they are said to be logically equivalent. The contrapositive and the conditional are logically equivalent. So look at that last one. If angle 1 and angle 2 are vertical, then angle 1 is congruent to angle 2. Is that much easier to think about? Yeah, okay. Now you might be thinking, well say I could have gotten that answer first regardless of going through all the work and coming up with those 4 statements. There will be situations when the first statement is very difficult to think about, okay? Much more difficult than this one is, which coming up with the contrapositive will then be a benefit, okay? But this is easier to answer. Is that true or false? That's true, right? Okay. So if they're vertical, then that tells me that that top one is true as well. Okay. So the conditional and contrapositive are both true. Now that doesn't tell me anything about the converse and the inverse. Okay. When I look at the converse, it says if angle 1 and angle 2 are not vertical, then angle 1 is not congruent to angle 2. I don't like that one. Okay. I try to decipher that one. I struggle with it. Let's see if I go to the inverse and answer that one better. If angle 1 is congruent to angle 2, then angle 1 and angle 2 are vertical. Okay. Think about how we answer this. Remember yesterday we said we were trying to decipher whether a conditional statement is true or false. The verbiage they use is that every time the hypothesis is true, you have to be able to show that the conclusion is true. So every time, and I think that's kind of weird to think about when they say every time the hypothesis is true. Basically what they're saying there is that every time that the hypothesis is occurring, every time that you have an angle 1 congruent to angle 2, that's happening in front of you, either in your homework question, a test, okay, just notes, whatever. You have 2 angles in front of you, and they're congruent. Okay, what this conditional statement is saying, if that is occurring in front of you, then you have to be able to make the statement that angle 1 and angle 2 are vertical. Is that true or false? Or are there counterexamples that would violate that? That's false. Okay, and that's false because there are, basically what we're saying here is that if you have 2 angles that are congruent, the only way that they can come and be presented is in a vertical nature to one another. Okay, but we know from what we've done before that we could be provided maybe angles like this. Would you guys agree that angle 1 and angle 2 right there are congruent? Both right angles. Okay, but are they vertical? No. So we have this happening. We have that in front of us. That's true. Angle 1 and angle 2 are congruent. That's happening right here in our picture. Okay? But we cannot come across the conclusion then that they are vertical. So this is that's a counterexample of why that's false. And there's a lot of other counterexamples. You know, I could have angle 1, okay, maybe that's 30 degrees, and then I could have angle 1 over here, or angle 2 over here, and it also have a 30-degree angle, okay? And they're obviously not vertical, right? Okay, I could have one in one hand and the other one in the other hand, not touching at all, still be congruent, but not necessarily vertical. So that's a false statement. So what's that telling me about a converse statement? Yeah, this one's got to be false too. Okay? Because these statements, guys, always come in pairs in regards to their truth values, you can have all 4 true or all 4 false. You have 2 true and 2 false, but you can never have 1 true and 3 false or 1 false and 3 true. Okay. In a good portion of some of the assessments we have in this class, tests and quizzes over this chapter, I'm going to give you a handful of these things written out, or that you have to write out, and then decide whether they're true and false. And that's the idea, is that hopefully we only have to answer 2 of those. Okay. Because here I really only had to answer the contrapositives, true or false, and then I think I answered the inverses, true or false, right? And that automatically gave me the other 2. Okay, so it's kind of a time saver. All right, so what does that kind of lead us into? Okay, that leads us into what we refer to as biconditionals. Okay, I deleted a lot of the background stuff out of this slideshow because it was getting in the way of some of my writing. But this is a nice progression into this concept. Some textbook will actually put 2.2 and 2.3 in the same section. Okay, so we're breaking it up in 2 days. A lot of times they do it in 1 day in a text. But biconditionals and definitions. What's the prefix bi mean? It means 2, right? Okay, so if we think about this, this means we're going to have 2 conditionals. Okay, and then later on we'll see how that progresses into definitions for us, and how that can relate to definitions. We'll talk about biconditionals. Okay, so I'll give you the definition here of what a biconditional is. Okay, a biconditional is a single statement, a single true statement that combines a true conditional, so a true original statement that we've been talking about, a true if and then statement, and that true if and then statement's converse. Okay, so this is going to give you the original. So here's the idea: is we start with an original, we decipher is it true or false. Okay, if it's true, awesome. Let's find its converse. Now we decipher if the converse is true or false. If it's true, that's even better, because now we have a true conditional and true converse, and we can better write that as what we call a biconditional. Okay, and we combine it into one phrase. So biconditionals are written by joining the 2 parts of each conditional with the phrases if and only if. Okay, and there's an abbreviation for that phrase, IFF. Okay, so what we're doing here, guys, this is a different structure. Okay, if I give you a conditional statement, an if-then statement, we talked about yesterday, and I'm trying to belabor this point to you. If in your textbook or in notes or whatever I give you in front of you in class, and it's a property or a statement that says if whatever, comma, then whatever, that is the only way we can use and apply that information. Okay? But if I give you a phrase in class that uses the phrase if and only if, we treat that differently. Okay? Can I show you how we treat that differently? Okay? Remember yesterday I said an if P then Q phrase is not reversible. If I provide it to you in a text or a note that way, right? Okay? If I provide you an if and only if statement, they're telling you with that structure, that phrase is telling you essentially if this thing is reversible. You can flip-flop it, flip-flop the order in which you read the P and the Qs, and you can get new information or additional true information. Okay, so can I give you an example here? All right, so here is a conditional statement written here in blue. That's our original. Okay, so to write my original, I'm going to write original conditional. Okay, let's read that. It says if the sum of the measures of 2 angles is 180. If you have in front of you 2 angles who are adding up to 180, can you always make the conclusion then that they're supplementary? 2 angles in front of you, they sum up to 180. Can you always say they're supplementary? Yes. Okay. So this is a true statement, right? So we got the one part. We got a true conditional here. Let's see if its converse is true as well. So take a minute, write what you think the converse would look like. All right, so when my highlighting is terrible, but when we get that first conditional statement, we can highlight the purple stuff as our hypothesis and the yellow stuff as our conclusion, right? The converse of that is just flip-flopping those spots then. So I put the yellow first, two angles are supplementary, and I put the purple second. The sum of the measures is 180, okay? Now, when I put that purple thing second, it is not verbatim. It's not word for word what I started with in my first conditional, right? Okay, because I didn't put, the sum of the measures of two angles is 180 there. I took some stuff out, but that's okay because I didn't take any math content out, right? Does that make sense to everybody? And you can do that. Just make sure that when you maybe rewrite your hypothesis or rewrite your conclusion, you leave things out, or maybe you add things in to make the grammar flow a little bit better, that you don't add anything new mathematically and you don't remove anything mathematically, okay? But would you guys agree if that's the converse? Is that a true statement? If two angles are supplementary. So right now I'm going to give in front of you two supplementary angles, okay? Does that mean that their sum is 180? Yeah, there is no counterexamples to that. So this is a true statement. This is the converse. This is the converse, and it is true. So we have this aspect of the definition of a biconditional as well. So that means because both of those are if-then statements, and they're converses of one another, and they're both true, we can do a better job of writing this statement. We can write this as one concise statement that incorporates both of those sentences. And this is the way we do it. We choose one of those. It doesn't matter which one. Okay, so I'm going to choose that top one. And let me just do this because I think it's easier to see on how to create a biconditional this way. You're going to go find the word then. Okay, so if you've said that, yes, I've got two conditional statements that are going to set up a biconditional, take one of those biconditionals, find the word then, cross it out, rewrite in its place if and only if, come to the beginning, delete the word if, and you're done. Okay? That then is what we call the biconditional. I'm going to write it, I'm going to type it in here so you can see it kind of in its entirety, but we would have the sum of the measures of two angles is 180 if and only if the two angles are supplementary. Okay? Now that phrase, that blue phrase right there, is a biconditional. It's a similar structure to a conditional statement. Think about my conditional statement. Was this here that I'm underlining, is that your P statement? Okay, I'm going to underline Q or my conclusion twice, right? Is this still P right here? Does that make sense to everybody? Is this Q right here? Okay. Now here's the way we interpret it and read it differently. Because it's a biconditional, and because we see that phrase if and only if in there, it means I can read this thing from P and get Q. So start with P phrase, you get the conclusion of Q. So start with sum of measures of two angles is 180, I get then that the angles are supplementary. But because it's got the words if and only if in it, this structure tells me you can read this, you can reverse it, you can read it right to left. You can start with Q and then get P from that. Does that make sense? Start with two angles that are supplementary in front of you, then you get P, the sum of the measures of the two angles is 180. All right? So when you're dealing with a biconditional, it's all predicated off of this phrase right here, if and only if. That tells me, that's the structure that tells me it's reversible. And you can reverse the phrase like you want to. Okay? But if I get the word if and then, published by the author in a textbook or by Mr. Fay in notes, we're going to make the assumption that it's not reversible until told otherwise. Is that right, everybody? What's the benefit of this? Okay? If I want to, as an author or a publisher, relay information to people, okay, I have just within, looking at this state, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 words. In 19 words, I have told the exact same thing that maybe these 40 words would tell me. Does that kind of make sense? So I'm able to say the exact same thing in a much more concise manner. All right? And it's just something that we as mathematicians have developed a process for. And we have to, if you're learning this stuff, you have to realize that and recognize it so that when you come across an if and only if statement, you know how to interpret it. Okay? You know, if you're in English class or and you see exclamation points and question marks and commas and semicolons, you have to interpret that structure, right? Okay, a question mark tells me something completely different than an exclamation point. A semicolon tells me something completely different than a colon, right? And it's the same thing no matter what language you're in, whether it's Spanish, whether it's you know, English or mathematics is a language, right? So we have to understand that structure so that we can take these phrases and apply the rules that are presented inside these phrases. Now, I took the top if-then statement and canceled out the then, replaced it with if and only if. I could have taken this one here, taken out this then, replaced it with if and only if, got rid of that if, okay? Because if this one was reversible, if I can read this left to right or right to left, when I read this one right to left, from this end to that end, doesn't it give me this phrase here? Does that make sense to everybody? Okay, read this one right to left. The two angles are supplementary. That's what this is saying right here. If and only if, the sum of the measures is 180. So both of these say the same thing. Okay? So you might write it differently than your neighbor because it's reversed. But that's what we're allowed to do. That's what the if and only if tells me. Okay? You may see, and it's again because mathematicians don't like to write this phrase out a lot because of how often it becomes a common phrase. We use the phrase, the letters IFF. Okay? It's just an abbreviation for the phrase if and only if. I've had students and even classmates when I was in college think that was an abbreviate or a typo. They think it's just the word if. Okay, but somebody got sticky fingers and got IFF. It is an abbreviation. It's a shorthand for that phrase if and only if. Okay, so that means we can reverse things. Now, that's going to help us get into an idea here in a little bit about the fact that if I look at that, is that simply telling me the definition of supplementary angles? Okay, that's a key thing for some biconditionals. Okay, and this one's being able to written as a biconditional because of the fact that it's a definition. And we'll get to that here after we do this example. So here, questions that they're going to ask you to do is say, okay, now that you can take two biconditionals and scrunch them together, or sorry, two conditionals and scrunch them together as a biconditional, can you undo that process? Can you start with a biconditional and then decide what are the two things that it's trying to tell me? So when I do this, it's just reversing the process that we went through previously. I'll start with this biconditional right here. So the ray is an angle bisector if and only if it divides an angle into two congruent angles. If you remember what we did in the last one, we replaced the word then with if and only if, right? So now I'm going to undo that. I'm going to find if and only if, and what do you think I'm going to replace it with? Yeah, I'm going to cancel that out. I'm going to replace it with the word then. If you remember, then the next thing we scribbled out the if that was in front, right? Well, now I'll put it back in. And if I write that out, oops. Okay, so if, my fingers don't want to work today. If a ray is an angle bisector, then it divides an angle into two congruent angles. And that is one of the conditional statements that is encapsulated inside that biconditional that we started with. Okay? If that's one of the conditional statements, and we know that a biconditional is made by a conditional and its converse. Once I have that one, can I flip it? Okay, so find that one's converse, so I should be able to say, if it divides an angle into two congruent angles, then it is then the ray is an angle bisector. And there's some grammar things that you could do there in that second one. If you want to introduce that you're talking about a ray before you say it, does that make sense? I could, at the beginning, probably say, if a ray divides an angle into two congruent angles, then it is an angle bisector. I think initially when you're reading a sentence, you like to introduce what you're talking about first, right? Or as soon as possible. So you can do that. That grammar is not a problem. But those would then be the two true conditional statements that we're interested in, okay? Down the road, we're going to prove some stuff. We're going to prove an if and only if statement. Well, if I want to prove a biconditional, the way we go about doing that is we actually break it up into two problems. We break it up into that conditional and we prove that one, okay? And then we break it up into that one and we prove that one. And usually the way we prove those is a little bit different because we start off with different information, okay? Does that kind of make sense? But the strategy or the structure, I guess, of them writing these things, we have to understand what information is trying to be told to us based on these phrases, if and only if, and that kind of stuff. If you see this symbol here, okay, so yesterday, if it was P, arrow, Q, it meant that was if P, then Q. And that's the only, that arrow is saying you can only start at P and then go to Q, right? You can only read it that way. If it's a biconditional, we do that. And that tells me now that I can read it from the left to right or right to left, okay? And ultimately ends up being a reversible statement, okay? Now, how does this relate to definitions? And we're kind of running out of time here, but I think we can knock this out in the next 3 minutes. A good definition has three aspects to it, okay? A good definition uses clearly understood terms, meaning that we're going to use terms that we already have defined, okay? I don't want to have to define something in chapter 3 with a word that I'm not going to learn until chapter 7. Does that make sense? Okay? So we're going to, when we're in this class, in any math class, we're going to define a object with previously learned terms, things we've already discussed, things we've already defined. You've all been reading a book before, and you get to a word, you don't know what that word is, so you look it up in a dictionary, and then when you look it up in the dictionary, inside that definition is another word that you don't know, right? So you got to look that one up, and you got to keep playing that game until you figure out all the words so that you can analyze the one word that you were missing in your novel. We don't want to have to do that, okay? We want to make sure that everything is clearly described using terms that we're all comfortable with and understand, okay? The next aspect is that it's precise, okay? We don't use words like near or far or large or most of or almost. Those phrases are vague, right? Okay, I might be near Alex right now, okay? I still might be near him, but now I'm far away from him. Well, there's somewhere in between that last instance of being near and that first instance of being far, that was the cutoff that distinguished near and far, right? In our definitions, we would want to describe what that cutoff is. We can't just say near or far or sort of or something like that. We don't want that vagueness. The third thing is what this lesson was targeting. A good definition is reversible. A good definition, I can give you the definition, you give me the vocabulary word. Or I give you the vocabulary word, you give me the definition, right? Okay? It's reversible, meaning a good definition, if it's reversible, a good definition can be written as a biconditional. Does that make sense? Okay? Now read that because we can have an if-then statement here. If it is a good condition, or sorry, if it is a good definition, then it is a biconditional. Does that make sense? That's an if-then statement. So if I start you with a biconditional, can you say it's a definition? You can't. Okay? Because I told you if it is a good definition, then it is a biconditional. And I'm giving you that phrase as a rule, so you don't want to reverse it if it's written as an if-then, right? And when I say, if I start you with a biconditional, can you make an argument that's a definition? That would be effectively reversing that, and we don't want to do that, okay? So basically that last statement says a definition can be written as a biconditional, but not every biconditional is a definition. Does that make sense? Okay? We'll have biconditionals that talk about properties and rules and that kind of stuff that aren't addressing how to categorize or organize objects, okay? There is an assignment 2-3 in Math Excel. Did I tell you I messed up the due date on 2-2? Okay, so I'll also open up 2-2, and you guys can finish that up tomorrow. I don't anticipate too many issues